going to put some light onto our solar cell. Let's see how it happens when it has light on it. And when I cover it up and apply some shade, it simply stops. Now go, now stop. So of course that has some advantages, but what do we want to do? What can we do if we want the car to move even in the shadow? Well, we add this little device, the supercapacitor. So to fasten this to your car, you need a single cable tie, and what you're going to do is lift off that solar cell and thread the cable tie from underneath the car through one of the holes in the body and poke it down into the other hole. So you've got this nice loop. Both ends should be sticking out on the bottom of the car, and on the top you'll take your capacitor and slip it into that hole, that loop. Now you can fasten the cable tie on the other side. Whoop. Note that you want your wires to stick out the back of the car. If that's nice and tight, you can snip. Keep that neat. And we're going to add a little three-way connector. So there are 3 places where you can add connections. And we're going to stick this into the 2 wires of your capacitor. And now, let's leave the solar cell alone for the time being. Get that motor connector and stick it into your 3-way connector. Red to red and black to black once again. Can you see those wheels turning a bit? Perhaps we'll change the pulley ratio so you can see it more clearly. So your car can move, but your wheels can move, but your car can't at the moment because the capacitor is not charged up enough. So this stores charge, you see? Now when we connect our capacitor up to a special device called a multimeter, we can read the voltage across that capacitor. So I'm just connecting the capacitor to the multimeter, and I'm also going to disconnect the motor. Oh, slipped out. Disconnecting the motor and connecting the solar cell. Now the reason I'm doing this is because I want to show you what happens when you charge up your car in the sun or under a lamp. I want to show you what the multimeter is displaying as you charge up your car. So let's have some light. Now that the motor is disconnected, your car is not going to go anywhere while you're charging, which is a good thing. And as you can see, that reading, the voltage, is going up quite quickly, really. And that means your capacitor is charging up. It should take about 3 minutes for your capacitor to charge up fully through this solar cell. And the reason for that, the reason it takes, and it will charge up to about 2 volts. Reason being that the solar cell can only reach about 2 volts. The voltage is now starting to stabilize, and as you can see, it's just over 2 volts. Your capacitor is not going to store much more than that, at least not when it's rigged up with this solar cell, because this solar cell can only reach 2 volts or a little bit more. So now that it's basically charged up, we can disconnect the solar cell and connect up well, let's get rid of the multimeter first. Now we can also connect the motor to the capacitor, red to red and black to black. Let's ensure the pulley ratio is all right. It's good to check these connections. They can slip out quite easily. And whoa, look at those wheels spinning. Turning quite quickly. Now my car's not going for it, probably because of the friction. Too much friction somewhere.
Panel. Your panel is touching your front wheel.
And also because the panel is touching the front wheel. Thank you, go ahead. So let's, ooh! Now it's running away. Okay. The ultimate configuration is with all 3 of your main components connected. So take your solar cell and connect it to your capacitor first. Red to red and black to black. And now connect your motor to both of these to both your cell and your capacitor. Why do we do that? Well, now your car can run both in sunlight and in shade, and it will go for as long as it takes for the charge in this capacitor to be used up. And there you have it, your very own solar car. Well done. Of course, this is not the only possible design for a solar car. Have a look at this one here and see if you can spot the differences. Why not pause the tape before I tell you all the answers? So as you may have picked up, the pulley system for this car is a little bit more complicated. There is one more pulley, so you can achieve more combinations, more pulley ratios. This car also has bigger wheels. Cut that bit please, because they actually don't. This car is perhaps a little bit more stable than this one. And it's also a front wheel drive. It's designed such that the front wheels these big wheels, are in front as the car moves. Whereas for this one, the big wheels are behind. You'll notice that instead of having a front wheel, a small front wheel, this car has a single wire that just rests on the ground as it moves forward. Also, the placement of capacitor and motor is slightly different on this car. You may like to experiment with the placement of your capacitor and motor. So what are you waiting for? Go and design your own. Okay, and then should we perhaps have
3, 2, 1.
You can even change the power setting of your car. Let's see how we can do that. Let's say that you want to transport a drink like this from one end of the table to the other. I'm going to connect my motor to my capacitor, and as I do that, have a look at that pulley ratio at the front. Let's see if this car is going to transport that drink. Is it? Oh, it's hardly going anywhere. Okay, I'm going to change this pulley ratio and ta-da! It's moving. slowly, but it's happening.